So, quick update with the Commodore 64 running the code with just the characters layer, second characters layer from Sinway. This one, the first one's from PCBWay, and then the PCBWay sprites board, and this is the PCBWay video board. They're all connected up with the relevant configuration, so I get a good screen, which is the same boot up screen as here. And if I press, this is the emulation, obviously. The emulation then shows the bouncing balls with the ability to move the player sprite around a bit, and of course the balls destroy the bricks. And if I do the same on here too, I get the same, which is always nice to see. So actually that means the sprites board, which is more complex, is actually working. So that's good. I did just test it with the tiles board connected, and the tiles board seems to have a logic contention issue feeding back through to the address lines or the EBBS lines. So hopefully that should be pretty easy to track down. But this is good. The sprites board is usually the harder one to actually get working, and actually, so things to note is that this sprites board uses different resistor pull-up values for the scanline RAMs here. I lowered the resistance initially. I think it was something like 5.6K or something like that. I've lowered it. I'll have to check on the schematic in the source control to see exactly what it was. But this new resistance here, which is lowered from the initial one, seems to work really quite well. I'm very pleased with that, because that was a relatively significant design change. So that's good that all seems to continue to work. I'm just going to test the other timer-based multiplexing now, which is this demonstration here, just to see what happens. So reset Commodore 64, run with my easy flash, and hopefully, wow, look at that. It's fantastic, it works first time. So for those not familiar with this, this is an example of timer-based multiplexing. So I'm using the Commodore 64 timer interrupt to count the vertical raster positions it goes down the screen here, and then what I'm doing is that the CPU, or it could be an interrupt, but I'm using the CPU in this to wait for this line here, and then I'm disabling the sprites and updating their registers and so on and so forth. So basically, sprites update, sprites line update, sprites line update, and I'm going down the screen like this. So actually I'm multiplexing or displaying multiple copies of the sprites as the scan line marches down the screen. It's quite a common, just switching it to RGBS, it's quite a common technique for getting many more sprites out of the hardware than what you have initially. The Commodore 64 VIC chip also allows you to do that, and lots of different graphics cards allow you to do this. So that's cool, that's working really well. I just need to debug now the problem with the tiles board. I expect it's going to be a solid bridge, because when I plugged in the tiles board, and of course I had the EBBS lines set, then it was also corrupting previously working demos with the two characters boards plugged in, and the sprites board as well. The sprites weren't displaying properly, so yeah, I'm very much detecting that there's going to be one or more solder bridges on the tiles board. That's perfectly fine though. I mean, it's not great. I mean, I'm going to have to document where the solder bridges were, and then I'm going to have to feed back to PCBWay, I expect. Anyway, that's going to be debugging later on when I'm not so tired, and I'm really pleased with that though. I love seeing this demo because it's a really fantastic demo. Just a short little update. This is demo 7, but without the tiles layer, so it's demo 7 with 2 characters layers and the sprites layer. And this is the same demo running on the real hardware. So I still haven't debugged the tiles layer yet, but this basically shows that the 2 characters layers and the sprites layers all play together nicely. and we can see that we've got a nice full extent on the screen as it scrolls, and it all looks pretty nice and quite nice and rock steady, so I'm really happy with that. So anyway, now I'm just going to debug the tiles layer. And another short update. So this is the tiles board connected to the bus, but without any EBBS configuration here on the dip switches. And I'm seeing this. Now this indicates to me that there is a logic contention coming back through at least memory, possibly, because the sprites are not correct. I'm seeing this here. This also indicates that there may be, because I'm seeing these missing columns here. Now I know that sprites board works, so the missing columns would be caused by the bad RH values, for example. These vertical lines here could be caused by the sprite Y extent, or they could be caused by bad RV. We'll see. While visually inspecting the tiles board, I did notice that there were 3 solder bridges as I was trying to debug the issue. The first solder bridge was found near pin 11 at U18, which is here, and pin 11 is this. Pin 11 is usually set to, as we can see down at the bottom here, VCC on the power net. And next to it there's a wire which is connected to net ED5. The solder bridge was across here, basically. The before picture and the after picture shows how the repair looked. The second issue is near pin 1 on U66. Near pin 1, it was actually a bridge across these 2 wires here. So these 2 wires here, there's this internal line here, and then there is this internal net here, and these 2 nets. If I show the net on the schematic and zoom out, it is 4P7R. 4P7R is the internal RAM for the screen and the color memory for the tiles board, and it was, I think it was these 2 nets here, A5 and A6. These ones were connected together incorrectly, of course. The before and after pictures under magnification show the problem very clearly. And the third issue was a solder bridge on pin 8 of U4. So let's go to pin 8 on U4, show on the PCB, and pin 8. This board is the rear view of the board, of course, so it's flipped left to right. And it was pin 8 and this via here. So pin 8 is normally connected to ground net, of course, and it was connected to this via here, and this via is the Y, one of the Y position signals. So if I highlight the net on the schematic, we can see here that the register for one of the Y positions, the net comes from here, which is P2, and it comes in here, which is the adder for the vertical position, plus the lower 4 bits of the scroll position, and then outputting the final lower 4 bits of the
real virtual screen position to actually look up all of the data. So these were the 3 solder bridges that I fixed.
Short debugging update. So one of the first solder bridges that I found was that U18 pin 11 plus 5 volts VCC was connected to the nearby via, which was ED5, and this would cause data contention issues on practically the whole bus. Now when I try this in the simulation with the same data captured via the emulated user port, I can see the same vertical strips in the sprites. Now this tells me, and also in the sprite data itself, but also these vertical positional changes as well for the sprites. So this gives me good confidence that these solder bridges won't interfere with the other boards when they're plugged in, because it won't be killing the internal data bus, but also the other issues that I found to do with the internal tile RAM addressing and also the tile scroll calculations. Now just quickly running through the demonstration. So this is demo 7 on the emulation, and this is the same code, demo 7 on the Commodore 64. Looks pretty nice. This is demo 4 on emulation and demo 4 on the Commodore 64. So if I take the joystick and I move the joystick around, we can see that the main character moves around quite nicely. I can also levitate up into the air and stuff like that too. So the left and right facing sprite here is actually accomplished using the hardware sprite flips. So everything looks pretty good. Pretty nice. Working quite well, I'd say. Oh, the only thing that I can spot at the moment is that the second character's layer is being drawn twice, and that's because I'm probably... Oh yes, that's right, because on the emulation I've got the last layer initialized as the mode 7 layer, but obviously the last layer on this one is the second character's board, and the second character's board is displaying the data from the previous demonstration, which was demo 7 just now. This is demo 3, so if I press fire on the emulation, then it's the normal bouncing around that ball demo. If I run demo 3 now on the Commodore 64, ding ding ding, there we go. Let's get the press fire, and there we go. Same thing, move around the bouncing ball and the balls bounce off the bat, like this. There we go. So that works quite nicely as well. On this demonstration here, this is just using the sprites and the characters layer. If I reset the Commodore 64 and run, what was it, demo 3, the anim variation. The anim variation actually uses the tiles layer. So this is tiles, there's a raster split in the middle. It's actually cycling through the various different tile screens to do this animation. Plus it's also scrolling in pixels as well, which is how the ship is bouncing around. So if I run this on the Commodore 64, here we go. Pink. There we go. And once it finishes, there we go. So, same kind of thing. Again, the last characters layer here is being used in the hardware. What I should do is that the last character layer here actually should be connected to the tiles board output, and there we go. If I change it to be the same configuration as the emanation output, then the last layer on the tiles now is being used for the background color here. Actually, there's a raster split hidden behind some black colored characters here in the foreground. So also that works quite nicely. And this is the emulation with the timer-based sprite multiplexing. And over here we have the sprite-based multiplexing. I'm forgetting to switch off the last tile layer here during the initialization, but that's okay. What I'm really interested in seeing here is that the sprite multiplexing with the timer actually works still, and it works really quite well. And the last demonstration here is demo 1, which is the RPG demonstration. Oops, I'm not. There we go. I can move around. And then here we have the same demonstration. And there we go. Again, that seems to be working quite nicely. The wider screen scrolls really quite nicely. Works really quite well. So good old Commodore 64 works really quite well with this. The output on this is more stable than the previous iteration of the video hardware. Less interference. Much more stable video output. Really quite pleased with that. Now the next thing to do is to complete the work on building the scale sprites layer, I think, so that then the last layer can be something like this. That would be really quite cool.